Okay, so how can I undo an exponential function? This is the main thing we're talking about today. And it's going to involve something called a logarithm. But first off, we got to talk about inverses, right? So you've learned about parent graphs, right? So we have x squared, we have x cubed, we have y equals x, absolute of x, root x, 1 over x, b to the x, x squared plus y squared equals 1. For each parent, write an inverse equation. If you can, get y by itself. Okay. So here's what I'm going to do right now. I'm just going to kind of just do it really quickly. And then have you guys copy, and then we'll just talk about it. But for now, it's going to be kind of passive. I'm just going to kind of just do this really quickly. Do you guys see what I'm doing every time? What am I doing, guys? Just flipping the x and y. That's all I'm doing. Not that hard. Okay. Speed racer. Okay. So yeah, I just switched to x and y, right? X equals y squared, x equals y cubed. X equals y, x equals absolute of y, x equals root x equals 1 over y, x equals b to the y, x squared plus y squared equals 1. Or y squared plus x squared is 1. So, okay. Okie dokie. Now, can we get y by itself? Can you get y by itself for 1? Let's look at that one. How would you get y by itself here? What would you do? Square root it. However, we got to put plus or minus as well. Don't forget about the plus or minus. Can I get this one by itself? What would y be if I got it by itself here? Y equals what? Cube root. And you don't put plus or minus, by the way. It's only for even rooting. Only for even roots. You do that. Well, this one's already by itself, right? Whoop-de-doo. It's all by itself already. This one's a tricky one. I'm gonna write. I don't expect you guys to know this, but I'm gonna write this anyway because I don't want to say it doesn't exist because it does. And we're not going to cover it this semester. You guys will cover in pre-cal. But if I do teach you pre-cal next year, I'll say, hey, remember this? You'll probably say no because you got more important things in life than this stuff, but it's okay. It's called a piecewise function. I broke into two pieces, right? Y equals x and y equals negative x, right? So if x is greater than or equal to 0, yeah, because if x is positive, it's just going to equal x. If x is negative, it's the negative cow part. So that's all. But I don't expect you guys to know that. That's not for algebra 2 just yet. Jeff, go ahead. No, because it's going to always come out as positive. That's the thing. See, here's the deal. Here's what's happening. The absolute value is this, right? So that's y equals x, and that's y equals negative x. It's actually two different lines, but it's a portion of each of those lines, right? So actually, that's actually a good way to teach. I just discovered that way of teaching this. Yeah, because that's y equals x, and that's y equals x, but x is positive, right? So we only take that piece. This is y equals negative x, and x is negative. It's that piece. That's what's called piecewise function. But this is something that you're going to explore in pre-calculus, not in algebra 2. So it's not part of our CPM curriculum for this year. And then the other ones I'll do up top because I'm running out of space. We'll go pink here. How would you get y by itself for 5? What would you do? Yeah, totally. How about here? What would you say if we have to multiply both sides by y first? Yeah, it just gets back to the same thing. It's itself. Yeah. This one I haven't taught you guys yet. Let's wait on that one. We're going to do that today. And this one it just is. Actually, you could get y by itself. Y squared equals 1 minus x squared. y is plus or minus root 1 minus x squared. So like back in the day before Desmos existed, when you had to actually graph this kind of equation that you had to get minus. And so you had to be able to do like, okay, we'll smooth x squared over the square root. Oh, I got the plus minus. So you have to write two separate equations. Root 1 minus x squared, negative 1 minus x squared. If I actually were to type in Desmos, or just type in the equation like that, you get the same thing. Desmos is nice because you don't have to get y by itself. You just put a really crazy equation that does it for you. It has a much more sophisticated algorithm than the TI-84 calculator. So that's what Desmos is good. And do I have any? We don't have any. Do there any juniors in here? Yeah, yeah. Are you taking the SATs coming up soon? Yeah. So you have to use Desmos. And for the sophomores, you guys will do the SAT next. Or maybe you don't have to do it, but you probably will. But yeah. But like Desmos is part of the SAT now, so that's nice, right? Because you can just type stuff in. So, are you registered to take it? I mean, okay, got it. Good. Do you know where you're taking it? Okay, I know some people driving like up to like Fresno or yeah, or like Yuba City because so they're all full around here. The spaces have filled up so fast. Yeah, so it's also in the computer too. So I think it's an infrastructure thing. If they don't have the bandwidth to handle, I don't know. Anyway, include sketches. I can do this quickly. It's pretty fast. So for one, you get this, right? For two, you get this. Okay, I'll do 1 and 2 right now. The inverses are going to look like this. So the inverses are in green. The parents are in pink. And just honestly, just use Desmos. That's totally fine. Just use Desmos. It's okay. It's not a problem. By the way, on Desmos, you don't have to get y by itself and do the inverse. Like if you put x equals y cubed, they'll know to do that green curve for number 2. So if I go to Desmos right now, so Desmos, y equals x raised to the third power. Sorry, x equals y to the third power. Or if I did y equals cube roots, that's a little frustrating. I have to now pull this up here. Functions, where the heck is it? Yeah, it's kind of annoying. There we go. Yeah, you get the same thing. So it doesn't really matter. That's what Desmos is nice. Okay. If I do the other two, let's do it now. Y equals x, easy peasy. 4. You get that. That's also not hard. If you do the inverses will look like this. It's still the same thing, right? So the inverse in pink is still the same thing. And then for this one, remember it's symmetric about, it's going to look like this. It'll look like that if you rotate it. For 5, remember the radical looks like that. But if you do the inverse, it looks like this. Wait, no, hold on. It was x equals root y. Oh, sorry. It was like that. My bad. That was the inverse. For 6, they're the same thing. If I do it again, so yeah. So sometimes they're the same thing. That happens. But every single time, you need symmetry about y equals x every single time. When you graph the original and the inverse, every single time. For 7, if you graph that one's going to look like this. If you graph its inverse is going to look like this. And you can actually do that in Desmos really quickly. If I do like y equals, say, 2 to the x, right, as an example, did x equals 2 to the y. Oh, come on, man. There we go. Yep, there we go. And then 8, that's just a circle. And guess what? The inverse is the same circle. Because, they're symmetric about y equals x. Easy peasy. Okay, any questions? No? All right. I know that was kind of long, but we need to make sure we have the discussion. And then is anything inverses of each other? So which ones were the same? The original and the inverse were the same. When did that happen? For which ones? Y equals x, and there's another one. Totally. There's one more. No, 1 over x. Y equals 1 over x is the same thing. Yep. The rest all have differences. Do any parent functions have inverses are not functions? So which ones failed the horizontal line test? Totally y equals x squared. What else? 8 for sure. Yep. X squared plus y squared. Also, the absolute value. That also failed it too. And actually, I kind of goofed when I switched x and y. I was actually supposed to say this. But anyway, it's neither here nor there. Just don't worry about it. I kind of goofed with that one. Okay, good. So this is just make sure you guys are comfortable with inverses, right? Now we're getting to the heart of the matter, right? Let's look at an exponential function. Let's do its inverse. But before we do that, we really need to make sure we understand what's happening with the exponential function, right? Very important we understand what's happening with it. So let's make a table. Super easy. X and Y. I'll do 0, 1, and -1. So what happens when you plug in 0? What do you get? 1. When you plug in 1, you get what? And 1/3. Okay. So you have that, and you have that. And in steady hands, I really need to get my stylus fixed here. I'll go to IT later today. Yeah, you got that. Okay. So you guys might remember that from last semester. So I've done the table. I've done the graph. The domain. Is there any restriction for the domain here? Is it all real numbers? Okay. Now, all real numbers. Now, here's the thing, and we're starting this today. We're going to start writing domain and range a very standard way. And this is going to be the way the rest of your life. The rest of your life, going to write it this way. Because we have to start writing it in this standard way for pre-calculus and calculus and beyond. So we're going to write it like this. This is called interval notation. I know you guys want to write all real numbers or ARN because that's what you're used to from middle school. Well, we're not middle school anymore. We're in the big leagues. So we have to start doing things that are more standard to what other classes are doing, right? The future classes. So when you see this, this is what it means. You put the lowest number to the left, the highest number to the right. Why do I put the negative base to infinity? Because if it's all real numbers, is there a lowest bound? No. Is there a upper bound? No. So you write it like this. Now, why do you put parentheses? Parentheses mean it's not included. So I don't know what infinity is. This abstract idea. Like this number just keeps getting bigger, bigger, bigger. I don't know where it stops. It doesn't stop. It keeps going, right? The range, I'm going to write like this. What's the lowest y value? Or what does it get very close to? But not exactly, right? So you're going to write like this. That's how you write the range. You write like that. This means not included. When you have a parentheses. And just for fun, let's look at a parabola. Let's say the vertex was 2, 3. Your domain's all real numbers. The range, what's the lowest y coordinate here? Well, for what I just drew up to the right. No, for this one I drew. 3. Yeah, I mean, you're seeing part back. Don't worry about it. But that 3 is included. So in this case, the bracket means included. So I'm going to be doing this. I know I should probably do a lesson on this, but I'm just going to kind of just trial by fire. Like, let's just start doing it now. And as I do just more and more, it'll just sink in. Because that's how we really should be doing it. And I will say it was mildly annoying. I mean, it's first world problem, but when I'm grading finals, so everyone's writing domain. I just tell the other L2 teachers, we just got to just tell them this is what it's going to be like, right? Here's what you got to do. I think by now you guys know what domain means, know what range means. We'll just write it the right way. So, kind of like if you take a language class, you want to be able to pronounce things correctly. Same thing here. You want to do things the right way. Asymptotes is going to be this. And that's going to be y equals 0. So this is actually looking at end behavior, just so you know. It's not a boundary, because you can cross horizontal asymptotes, by the way. They can't be crossed. We'll see later on in the semester, they can't be crossed. It's more about end behavior, because as x gets really tiny, or x gets more negative, right? Like if I put it to a negative like 10 power, let's see what happens. What if I did I'll go to this hokey calculator here. I think there's a scientific version of it. Yeah, scientific. So what if I did 3 raised, where the heck is it raised? Raised to negative 10. So that's a really small number because it has scientific notation there, like 1.69 e negative 5. Or let me actually do it in TI-84 calculator. It's probably a little better. Let's see here. Dropbox. This is my 2022 folder. Math. Wabbit EMU. Let's browse. Open this file. Finish. Clear. Yeah, if I did like 3 raised to, like, say, the negative 5 power, see, that becomes a smaller number, right? So that's why we have an asymptote in the first place. An asymptote, and this is the one area that you guys struggle with on the final exam, and that's totally my fault. I don't think we taught it the right way. I probably should have followed Stephen's guidance a little bit more closely, and I just kind of taught it and didn't really give you guys a chance to understand it well enough. So that's my fault. But we do need to talk about asymptotes because it is a big deal for this unit, as well as the future units. When it's a horizontal asymptote, it's an axis end behavior. Like, what does the end of the graph do? This left end is getting closer to what number 0, right? So I put a bit more negative numbers, like between negative 5 to negative 10. It doesn't break the x-axis, it gets awfully close to it, right? And so I have to have some sort of thing to say about it, right? And that's what we call an asymptote. That's called asymptotic behavior, which we'll talk about a lot this semester. Okay, I know I wanted to deep end at that. Let's now move on to D. But A and B, I think, was pretty standard. C, I really wanted to deep end, but I had to do it. Now write the inverse. So how do I do the inverse again? What do I do with X and Y? Swap, and that's it. There you go. That's all they want you to do. And then they want you to make a table. Okay, let's make a table. That's not hard, right? But remember, what was our previous table? It was 0, 1, negative 1 for X, 1, 3, and 1/3 for that. Swap, right? You just swap it. So when Y is 0, that's 1. Or if that's yep, if that's 1, that's 3, and if that's negative 1, that's 1/3. So they just simply swap. So what did we have originally again? I don't know why I erased it. That was dumb. The original is this, right? And there was a horizontal asymptote. let's go blue for the other one. 1, 0, 3, 1. It's going to look like that, guys. And actually, there's going to be a vertical asymptote for that one. That one. So, yeah, what's up?
The bottom thing, what is that? Like
1/3, sorry. 1/3. Bad handwriting on my part. Thank you for asking. Okay. So, yeah, that's E. And then domain range. Okay, so domain, range, asymptotes. Let me write it down first, and I'll have a discussion about it. It will be x equals 0. It will be 0 to infinity and negative infinity to infinity. So what happens here, they swap from the original function. They swap.
for the original function. Swap. Well, think about it. What does x equal now? 3 to the y, right? I can put whatever off the y. Who cares? Y can be whatever. It's next button. So it should be all the numbers. But x is limited. Because think about it. If x equals 3 to the y power, 3 is a positive number. What's 3 to the y power means? Multiply 3 over and over again. Can I make that negative? Can I multiply 3 over and over again and make it negative? 3 times 3 times 3 times 3 times 3. Will ever be negative? No. No. That's why the domain's restricted. 0 to infinity. And it's the opposite of the original function. The original function y equals 3 to the x. X be whatever, but can y be whatever? No. Because y is like 3 times 3 times 3 times 3 times 3 for the original function. But for the inverse, it was x equals 3 times 3 times 3 times 3 times 3. So we have to be mindful and think numerically what's happening here.
Okay, but this is the big one, guys. This is the big drum roll moment. And this is the part, I hope I don't lose you guys. Ask questions if you get stuck, please. You know, it's totally fine. How do we get, this is the big question. How do we get x by itself when x, sorry, how do we get y by itself? My bad. My apologies. How do we get y by itself? That's and it looks weird. It's this new thing that we just conjured up, seems like. Y equals log base 3x. So let me tell you how you would say it. You would say it like this. Y equals log base 3 of x. That's how you would say it. And so what this does, a log allows us to isolate an exponent. That's what a log does. It allows you to isolate an exponent.
So if you want this isolated, it looks like this. So these are interchangeable. And that's gonna be a hard part to really fathom. I definitely expect some of you guys to struggle with it. Some might just get it right away, I don't know. But let's try some examples. Maybe as we do examples, it kind of sinks in a little bit. But that's what it means. It means, okay, if I want y by itself, then this is this way.
It's just another way of writing an equation. That's all it is. So a log is also another way to write an exponential so simply a rewrite. That's what it is. So can I clear the screen? Okay. So let me actually go to my calculator. This might be a good thing. This might help a little bit. So what if I did 2 to the 3 power? You guys just sit back and relax. What if I did 2 to the 3 power? What is that? We know that. What's that gonna be, guys? 8, right? What if I did like 3 to the second power? What's that, guys? 9, right? Yeah, not hard. Okay. What if I did this? Okay.
So what am I doing here? All right, so 2 to the 3 equals 8. What if I want to isolate that exponent, right? That's what log does, isolates the exponent. That's what it does. So if I want this to be isolated, what's the base of this power here? So it should be the base of the log. And what was my output originally? It was 8, right? So now that's going to be the input. So when I do this, it's like saying this. This raised that power equals that number. So if you undo it, it becomes this. So these are interchangeable. They're the same thing, just another way of writing. It will take some time to get the hang of it. But like, so if I hit enter, I'm gonna get 3.
Another way to think about it is like this too.
Log base 2 8 equals box. So 8 equals 2 to the box. Think like that. 2 to this power equals that number. 2 to what power equals 8, guys? 2 to what power? 2 to what power? 2, 4, 8. 2 to 3 power equals 8. That's what's happening.
Let's try another one here. What if I did, by the way, the TA4 calculus cannot do this when I was in high school. You guys are lucky that they have this subscript feature. What if I did log base 3 of 9? Okay. That's 2.
Just think about it. 3 to what power gives me 9? How many times I've multiplied 2 gets 9? 2. So it's like saying this. That's what a log does. If you isolate the box, then it becomes this. That's all it means. That's what's doing.
100%. So let's look at some examples here. I told you I have to do a lot of teaching today. So. And let's not worry about this whole puzzle thing, but if you just think about it, right? Like,
This thing's happening here, right? Log base 2 to 8 equals 3. So 2 cubed. That's because 8 equals 2 cubed. That's because 27 equals 3 cubed. That's because 25 equals 5 squared. That's because 10,000 equals 10 to the 4. Every single time that's what's happening here. You're simply taking the subscript and raising it to the power on the other side. And the answer is what was the input. Because guess what? The input now comes out. Inverses, that's all that's happening here. So we're going to do more of this just a second. Yeah, say a question. How do you get the log? Sorry, alpha window. Alpha window. My bad. I lost over that. If you go to the math menu, it'll be there. Whenever when in doubt, just hit math. You'll find it there. Just scroll down. But the shortcut is alpha.
Yes. Okay. So let's look at these parts here. So this is what I'm going to ask you guys. Let me put a text box for each of these. 2 to what power equals 16? And let me copy and paste that if it allows me to do that. Oh yeah, look at that. That's nice. So what do you guys think about for A? 2 to what power equals 16? Yep, it's 4. Yep, 100% correct. Let's look at B. 2 to what power equals 32? How many times you multiply 2 to get 32? Close, 5. If it was 64, you've been correct. If you had 64 next to the in place of 32.
So you multiply so 2, 4, 8, 16, 32. Choose the good powers. Okay.
Let's say I call this x here. This is like saying 100 equals x squared. What's x, guys? 10. Yep. Okay, we'll call this x over here. X equals 5 cubed. What's x equal if you need 5 cubed? 125. Yeah, good.
What's the shortcut to get?
Alpha window. Alpha, do you see on the left side?
Yeah.
Windows top row. Yeah. Same thing here. 81 equals x to the 4 power. X equals 3. Let's call this x here. 10 equals 100 to the x power. Ooh, that's a tricky one.
So wherever you see that question mark, put a variable that helps, right? That helps. I didn't do it for the first two, but I should have, I guess. You did 2 to the x equals 60, 2 to the x equals 30, that's okay. But 100 raised to some power equals 10. What would I raise 100 to make it 10? What do you have? Good. Yes, it's square root.
That's from last semester. Yes. Half. Exactly. Because remember, 100 to the half is like saying root 100. And by the way, come by during office hours. If this is still tricky, still confusing, don't worry. We'll take some time. I don't expect you guys to get it all today. We're doing this over 2 chapters, by the way, because we do know logs will take some time to absorb. And trust me, we're going to do logs on Thursday. We're going to do logs next week, right? So you guys will be fine. We'll be okay. Let's keep on trucking here. All right, so now we can go somewhat rapid fire, and then I should be able to finish up notes after that. Okay, I'm going to call these X, 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 and X. And every time I'm going to do a rewrite and solve for X. Yes, Sophia, sorry, go ahead, yes. Of course, yeah, totally, yeah. Okay. So 32 equals 2 to the X. 1/2 equals 2 to the X. 4 equals 2 to the X. 0 equals 2 to the X. X equals 2 cubed. X equals 2 to the half. 1/16 equals 2 to the X. X equals 2 to the 0 power.
You guys what I just did every time. Where did the subscript go? The subscript went to the other side, right? And where did it get risen to? What was on the other side? Whatever was on the other side. Wait, what happened to what's in the parentheses? Where'd that go? That go anywhere, stay where it was. What was in the parentheses, stay where it was, right? 32, 1/2, 4, 0, X, X, 1/16, X. Whatever was inside the parentheses, stayed where it was. Whatever the subscript was, moved over, you got risen to that power and some good stuff. So every single time we do this,
Every single time, we generally write like this. This is the big drum roll moment, actually, to be honest with you. Log base b x equals y is the same thing as x equals b to the y power. I know it's a little confusing because I'm using x on the other side, but this right here is the core essence of spring algebra 2.
What is log?
Yeah, what is it exactly? It's just another way.
it's honestly a way to help you isolate the X. So it's just a function. Is it W? No, it's a function. It's a function. It's an inverse function. It's an inverse function of this. But we need a way to write. So how do we write? This is something just kind of controversial. Hey, let's do that to functions. If somebody has the bias, it's this way where okay, if I want x to the next one, I need a way to move this b over it. So I'm gonna write like this. It really it's just like saying like, hey, if I have like 2 to the x, sorry, 2 to the y equals x. That's like that. Or if I like 2 cubed equals 8. So it's like actually it's like an operation more so, to be honest. It's really more like an operation. So you see this is like saying 2 to some power equals that number. So if I see log base 2/8, that's like saying 2 to some power equals 8. Or in essence, it's like saying 2. That is what this is. That's exactly what that is. It's like, well, it's not 2 to the 8th power. I know that's going to be some other number. In fact, that's 256. We worked it out. It's 2 to some power equals 8. And you got to find for that some power. What's that something? What is that something?
That's what it is. That's a log. So yeah, that's what it is, guys. A log is simply an operator that helps you figure out what is the exponents. This raises some power equals 8. What is that sum power? What is that? Or as an equation, if I want to rewrite this equation, you can do it like that too. Peter, go ahead.
Is that log meaning X?
Yes, that's a B. Yes, that's B. Let me write that more neatly. I should have been more cognizant of that. But how sad are your brothers and your dad about the Cowboys? Yeah. You know what? You don't really have to. I'm just gonna just say it. The owner has to go. Seriously, I'm on record here, so you can tell your dad to watch this video. Like, no, he's the one constant. Well, how could they haven't won a Super Bowl in like 30 plus years? He's the reason why. Because seriously, like when they won it, like there was no salary cap. You can spend all this money. Well, they've had other crap quarterbacks in the past too. Well, Tony Romo's okay, but he choked two playoffs. And they've hired all these great coaches over the years. I mean, if they hire Bill Belichick and they can't win, then it's pretty clear it's the owner. The owner needs to sell the same with the Raiders. Like, just Aldez son just terrible. Yeah. I agree. Honestly, the Warriors started becoming good when what happened? When the owner sold the team, and the owner came in. That's what happened. So
No, not really. They drafted Stephen Clay, and
okay, but still
then he sold it.
true. But they also traded away Monte Ellis after they brought in the right people. They brought in Jerry West.
Yeah.
You know, they brought in Bob Myers. Like they brought in the right people.
Bob Myers.
I'm just saying.
No, Bob Myers is not actually. I'm not sure to get that.
Okay, fine. It was Jerry West.
Because Jerry West got us Kevin Durant.
Yes, he did. And I've watched have you watched the show Winning Time? But yeah, I'm sad it ended.
It's like
It really should kept going another season or two, but
I think it was Jerry West or
Mhm.
someone is suing because
right. So Jerry West, because they thought they made him look like
they made
a total ass. Yeah. But I'm just sad they didn't at least go further into the Boston series, and then with Matt Johnson, you know, the HIV news. Like anyway, I hope another network or the streaming service picks it up. So anyway, let's solve these now. So now let's solve these. Because I do have to tell you what these equal, right? I can't just. Sorry, I got a little distracted there with the sports conversation. It's my fault. But you know, if the Niners lose, we are not going to talk sports for like the whole semester. All right. That includes you too, Jack. All right. Okay. What does X equal for this one? What would you raise 2 to get 32? 5. Good. What do you think X has to be here for B? -1. Good. How about for C? What would that be? 2 to what power gets you 4? 2. This one can't be done. Because you can't raise 2 to some power and make it 0. So what this, and remember the domain, right? Remember the domain was that X is greater than 0. Not X greater than or equals 0. Remember that. That's 8. That's root 2. Good boy. What are you guessing of this one here? 2 to what power gets you 1/16? -4. Good. And how's the last one? Yep, easy peasy. All right. So once you do, a lot of it's gonna be drill and kill. To be honest, I might have to do some drill and kill with you guys because just that's sometimes the way to do it. Okay, just got a couple more examples, and we're all done. And then what time do we get out today? Today's the 16th. Oh yeah, we got plenty of time. Oh yeah, you guys have plenty of time to get homework done. Yeah, be good. And Monty will be good too because I think you have to go in 10 minutes. You'll see the whole lesson. So, yeah. What's the equation here? It looks like the equation here is going to be log base 2x. I'll just tell you right now, it's log base 2x. Because if I do log base 2/8, I do get 3. If I do get log base 2 of 1/2, I do get -1. So, this is a little tricky here. So that's the equation, log base 2x equals y, or x equals 2 to the y power, but let's just leave like that for now. So log base 232, that's gonna be 5. Log base 21, that's gonna be 0. Let me just do these for you guys really quickly here.
How do we know that it's two? What is the function?
Let's back up a little bit, guys. Okay. Here's what's happening. It's not terribly obvious. It's kind of like saying this. 2 cubed, 2 to the -1, 2 to the box. But, you know, let me do it like this. This might help actually. The more I think about it now.
But how do we know it's two?
I got lucky. I just kind of tested it and it worked.
What do you do in tests or quiz?
I'm not going to ask a question like this because this is more just to help you understand what a log is doing. That's all.
You don't have to solve. You don't have to-
Well, let's come back to that. That's a great question, actually, because I actually love that question. If I gave some information, fine. But this is more just to help you understand what's happening with log.
Okay, so do you guys want to just did every single time? I said 2 raised to some power, right? So what's 2 cubed? 8. What's 2 to the -1? What happened? So that's the pattern. So 2 to the box equals 32. 2 to the box equals 1. 2 to the box equals 6. 2 to the box equals 4. And so forth. Ellie and stuff have been gone for a while.
If you might go check on him, bring him back. I hope they're not just hanging out. Okay. Thanks. I appreciate it, Evie. Okay. So 2 to the 5th power, 2 to the 0 power, 2 to the 4 power, 2 squared. I'll come back to that one. 2 to the 6 power, 2 to the 1 power. I'll come back to that one. 2 to the -2, yeah. Ooh, good. 2 to the that can't be done. 2 to the 1/2 power. Oof. That's tricky. Okay. So these are weird. So this can't be done. This also can't be done. This one you have to write as log base 2 of 3. And this one you have to write as log base 2 of 0.2. Because when it can't be done, so we have 2 to the box equals 3. Then the box equals log base 2 of 3. That just can't be done. So. Can't find them?
I think so.
Do you mind texting them? Okay, thanks. Yeah. And actually, it's a rare time I have to do this. I did this with a couple of students. Because then it becomes a truancy situation. It's not good. I don't want to have that conversation. sector, sorry guys.
I'm sorry, I got a blue nose right from the nurse.
Okay, I never got a note.
Sorry, that's my bad.
Okay. All right. We're still here. Okay.
Sorry about that.
Okay. Anyway, well, I'm glad you're back. Okay. Sophia, what took so long? Okay. All right. Well, all right, let's get back, guys. Is it recording? We share screen with you guys again. All right. Okay. Let's finish off. So anyway, the equation is log base 2x. So there we go. All right. So I know it's a little bit of a long-winded explanation. So y equals log base 2x. So why is the difficult thing of input when think of an output? And that's because you can't log 0 or negative numbers. And the reason why you can't do that is because, again, 2 to some power can't equal 0. 2 to some power can't equal -1. That's just impossible. So hence you can't log a negative number, because what this means then is log base 2 is 0 equals a box. But I don't know what that box would be. I don't know that, right?
Can you multiply by 0, so would it just still be 0?
No, you're not multiplying anything by 0. Let me go and clear the screen for a moment.
You're just entering it.
Yeah, exactly, because you have log base 2 of something, right? Hold on. Back up. Yeah, that's fine. You'll have the recording. So, I mean, you got most of what you need to do. So yeah, because the problem is that 0 equals 2 to some power. That's impossible. That just can't happen. And likewise, we have log base 2 of -1 equals a box. -1 can't equal 2 to some power. That's just impossible. It just can't happen. If I were to plug in 25, what would happen there? So log base 2 of 25 equals a box. So 25 equals 2 to some box. What would it raise 2 to? Or what would it get close to, right? Or in between what two whole numbers, I guess. That's the question. In between two what whole numbers would that be? What comes close to it? 5 or 2 to the 5th power is 32, so we've overshot. 4 or 5, exactly. Good job, Pierce. Yeah. So in this case, that box is between 4 and 5. Toy between 4 and 5. To the nearest 100th, don't worry about it. I'm not exactly sure. Yeah, go ahead. Some parts, yes. Some parts, no. There will be a small part that's non-cal for sure.
Question like, on a 5G,
Not quite that one. I would give you something like this. I would say, hey, log base 2 of 8. Tell me what that is. Without a calculator. Yeah, I totally ask that. That's fair. Okay, 69. Okay, now they give you the function. Okay, good. They give us the function. That's nice of them. If you plug in all these here, oof, this gets a little messy. Kind of don't like this problem. They give us all the whole numbers, right? For all the integers. So, not a fan of this problem here. Do I really want to do this? Well, let's just graph it first. Let me graph in Desmos. Okay. So hold on a sec. Okay. So let's graph in Desmos. So y equals log base 5. I know there's a way to do this, the shortcut. Sorry, guys. I'm a little rusty here. Yeah, so here we go. So you see there's a point at 1, 0. And 5, steady hands, right? Here we go, 5, 1, and so forth. So let's just plot the points. You know, let's not build the table. I think I've beaten you guys over the head pretty badly with logs today. So anyway, 1/5 -1 is like right here. 1, 0 is like right here. 5, 1 is like right there. I'm not even attempt to graph the others, kind of like way over here. So it looks like this. And these are a bunch of decimals. These are a bunch of decimal answers. You can plug in the calculator if you want to. I mean, I'll do one of them so you see what's going on. Like alpha window 5, 5, 6. You see it's like 1.113. So that's what you put for that one. So, okay. What do you notice about the results for g of x as x increases? It increases also. Also increasing. And then how use your table to draw the graph. Well, we just did. And how does this compare? They're inverses of each other. And I think is that it? It's a pretty long lesson, so I apologize. But we needed it today. Okay, I think we're all set. So the homework is attached. Initially, some of it's review. So it shouldn't be too bad. 61, I think, is pretty simple. 62 is review. 63 is kind of venturing into what we just did today. 66 is review. 67 is review. And then the last 3 problems, well, 77 is pretty easy. 73, 74 kind of gets into logs a little bit. So it doesn't quite get into heavy yet. It will on Thursday for sure. Okay. So we have about 20 or 15 minutes, I think. Is that right? Yeah. And just get to work, guys. Yep. Dave's good. Yeah. Yeah. I'll also let me stop my recording.